Fasten your seatbelts. It's going to be a bumpy ride. My name is Paul Williams, and I'm studying how climate change is really shaking up turbulence. Well, we know that in the United States of America, there are tens of thousands of planes encountering moderately strong turbulence every year, and thousands of planes encountering severe turbulence. By definition, severe turbulence is stronger than gravity. So anybody who is not seat-belted in their seat, any objects that are not restrained, food, drinks, will be lifted up from their resting place in severe turbulence, and that's why it's particularly hazardous. And these encounters are injuring hundreds of passengers every year and costing maybe up to $500 million in the USA alone. So there's always been turbulence, but what we're becoming increasingly aware of now in the scientific and meteorological community is that there is building evidence that that turbulence is getting stronger over time, and that climate change might be responsible for that increase. Flying through clouds is always a turbulent experience because of the convection within the clouds. This is the rising warm air exerting a force on the wings of the plane. But there's a different kind of turbulence called clear air turbulence, which is not in clouds. It's above the clouds and above the weather systems, and it's invisible. The pilot can't see it. Even the electronics on board the plane can't see it. This turbulence is caused by the jet stream, basically, what we call a wind shear. So the different layers of the jet stream moving at different speeds relative to each other, rubbing up against each other, and there's a kind of a friction, in simple terms, building up, which can become unstable, and that is the generation mechanism for clear air turbulence in the atmosphere. The carbon dioxide emissions that we are putting into the atmosphere by burning fossil fuels are, of course, changing the temperatures at ground level. It might surprise people to know that the climate is changing far up in the atmosphere as well, including 30 to 35,000 feet, where planes have their cruising altitudes. At those heights, the carbon dioxide is changing the temperature patterns, and that is, as a consequence, changing the wind patterns, causing the jet stream to speed up, and that's why carbon dioxide could be causing more clear air turbulence to be generated. Of course, we know that there's always been turbulence and there always will be, but we were the first people really to come up with the evidence that in future there will be more clear air turbulence because of climate change. There's some experimental technologies which may come online in the next few years. One in particular involves shining an ultraviolet laser out of the front of the plane, and that ultraviolet light, if it encounters any density perturbations that are indicative of clear air turbulence, invisible clear air turbulence, then the reflected light that is received back at the plane, in principle, could detect the presence of invisible turbulence by looking at the reflected ultraviolet light. Well, I was on a flight a couple of weeks ago from Chicago back over to London, and it was very turbulent for at least 1 or 2 hours over the mid-Atlantic. Actually, I've never experienced turbulence that strong before. And, you know, I work in turbulence, I know the statistics, flying is very safe, but even in the middle of that turbulence, there was a little voice in my head saying, this doesn't feel very safe to me, what's going on here?